Welcome everyone to BTT 151, Fundamentals of Electricity. I'd like to introduce your Unit 9 concepts. We're going to start talking about AC alternating current. So remember, a DC electrical system does not vary, the value of voltage does not vary with time. So the y-axis is going to be values of voltage, and the x-axis is going to be values of time. So for example, if we were to have a 12-volt battery, this is what the waveform would look like for a DC electrical system. That value of voltage does not vary with time. Compare that to an AC electrical system, and AC stands for alternating current, where we have our very traditional AC sine wave. So the expression that defines the sine wave, the V instantaneous, which is the instantaneous value of voltage at any point along this sine wave, is going to be equal to Vm or Vmax, which is the maximum value of voltage, multiplied by the sine of theta. Theta is the phase angle that corresponds to a particular location on the sine wave. So in this example, again, values of voltage are represented on the y-axis, and values of time, or electrical degrees, are going to be represented on the x-axis. So the sine wave starts off at 0 volts, increases to a positive maximum value of voltage at 90 electrical degrees, returns back to 0 at 180 degrees. Now it increases to a maximum negative value of voltage at 270 electrical degrees, and then after a complete rotation, it returns at 360 degrees back to where it started from at 0 volts. We refer to this starting here, going to 90, 180, 270, and then a complete rotation as one cycle. The frequency of this AC sine wave in the United States is 60 hertz, which means 60 cycles per second. Time and frequency have an inverse relationship, so time is equal to 1 divided by frequency. So to calculate how much time it takes for one cycle of the 60 hertz sine wave to occur, simply take 1 divided by 60, and we're going to get 0.0167 seconds, or 16.7 milliseconds. So what that means, I take the sine of the angle at any specific location on the AC sine wave, multiply it by the maximum value of voltage, and then it's going to give me the instantaneous value of voltage all along the sine wave. All right, so please this week take a look at the PowerPoint presentation, read the information in your text. Have a great week, and we will see everyone next week.